Alright guys, I'm back. We're doing 10.5, Surface Area of Pyramids, page 783. Alright, scan through the lesson and predict two things that you're going to learn about finding the surface area of pyramids. So do that now, pause the video. Alright, some things that you might have mentioned is that it's going to talk about using a net, that you're going to look into finding out about square and triangular pyramids and find the surface area for each of those. Alright, so it says vocabulary startup, and there's a lot of vocabulary that I don't know if you guys have seen before, but we definitely want to go over it. I've talked about slant height, but let's go over this, okay? A pyramid is a three-dimensional figure with at least three triangular sides that meet at a common vertex, and only one base that is a polygon. The triangular sides of a square pyramid are called the lateral faces. The slant height is the height of each lateral face. All right. So when we're looking at this picture, okay, we've got the tippy top here, which is called the vertex. Okay. Then we have trying to see if I'm missing something here. Then we have a vertical or a lateral face. I think that's what this is pointing to, where it's this. I have no idea. I can't tell what it's pointing at. And then we've got our slant height of the pyramid, which is represented right here at a right angle with the base of this triangle. It says that Claude made a model of a large pyramid in front of the Louvre Museum. His model is shown. Draw the faces of the pyramid. So what would the base be? It does say the bottom here, it says it's 5 by 5. So draw the different sides for me, and I'd like you to identify the sides as well, like the dimensions. All right, so pause the video and do that now. All right, so it should look something like this. We've got the square base, which is 5 by 5. Then we have the lateral faces, which are the triangles that are each with a base of 5 and a height of 3.5. All right, so surface area of a pyramid. Oh, good. I identified that lateral face correctly. All right, so it says surface area of the pyramid is the sum of the area of the base and the areas of the lateral faces. So just like we've been working with, we're going to find the area of each of the shapes that make up this 3D part and use those to find the surface area. When it's stretched out as a net, okay, and I love that they show that to you right next to each other so you can see what it looks like as a 3D shape and then also as a net. The slant heights aren't quite as obvious because now they are just a regular height to a triangle. But you just have to understand that that slant height isn't how tall this pyramid is. It's how long it is from the tip of the triangle to the base, outside base. Whereas if we were talking about the actual height of this, we would be going down to the middle of this, like think of a tent. It's not the poles, how tall it is on the sides. It's actually physically, when you stand up inside the tent, how tall are you inside that tent? I don't know if that makes any sense. But it's not always the same thing. If you were to stretch out that pole, it's probably very tall, but then whenever you use it to lean for the tent, it's not quite as tall anymore because it's slanted. It's the slant height. Hope that made sense. All right, some pyramids have square and rectangular bases. You can use a net to find the surface area of a pyramid. All right, so find the surface area of the pyramid, and this is another square, and I know that because my base and my height are the same, so that tells me it's a square. We're going to find the area. It says using the net to find the area of each face and then add them together. Whenever I do this, I like to color code, and I also like to write the numbers inside the shapes. So they've already made the beautiful net for us, so we're just going to use what they gave us. So finding the area of the rectangle or the square in the center is base times height, which is 7 times 7, which is in this case 49 centimeters squared. So I'm going to write 49 in here. Then using a different color, because I'm a handy person like that, I'm going to do the area formula for a triangle because these are triangles. And so we've got 1/2 the base, which is 7, times the height, which is 9. In this case, you might want to go ahead and multiply 7 and 9 together. Neither one of them are even numbers to get rid of our 1/2. So we can do 1/2 of 63, and so that's going to be 63 divided by 2, which is 31.5. 31.5. So in each of these, I'm going to put 31.5, 31.5, 31.5, and 31.5. So when I'm finding out how much this is all together, I'm going to add all of these sides. My base, which is the square, and the 4 triangles, which are the lateral faces. So maybe to save some time, instead of doing 31.5 plus 31.5, you might do 31.5 times 4, and then add the base, which was the square, which is 49. And either way, you'll get the answer of 175 centimeters squared. All right, so they've given us 2 to work on our own. I want you to do these. You've already watched the inquiry lab, so I hope that you've gotten a grasp of how to make a net, or just to look at this and figure out how many sides there are and how many triangles you'd have to do. So go ahead and try to do A and B on your own, and I'll come back with the answers and I'll show my workout. Pause the video now. Pause it. Thank you. All right, so I showed my net here where I drew an amazing net. Yeah, I know. So it's a 16 by 16 base, which is a square. And then we have heights, the slant heights are 12 feet on each of the triangles. So when I'm doing my area of the square, I'm doing base times height, 16 times 16, which is 256. And then when I'm doing the area of the triangles, I'm doing 1/2 of base times height, which is 16 times 12. I did 1/2 of 16 right away to get 8, and 8 times 12 is 96. So then I'm taking the 96, and there's 4 of these things that say 96 because there's 4 of these triangles that are the same. So it's going to be 96 times 4, which is 384, and then add that to the base, which is 256, and you find 640 feet squared. All right, guys, let's do B now. Pause the video. This one has a decimal in it. Pause the video, and we'll see how you do. All right, this one wasn't too bad. The base was 9, is the area of 9 inches squared, and then each of the triangles has an area of 6.75 inches squared, and that's times 4 because there's 4 of those sides. Add it to the base, and you should get 36 inches squared as your final answer. All right, so now we're going to look at surface area of pyramids with rectangular or triangular bases. A triangular pyramid is has one triangular base and 3 triangular faces. If the base is an equilateral triangle, then all 3 lateral faces are congruent. If the sides of the base triangle are different lengths, then the areas of the lateral faces will also vary. So basically, if you can get lucky enough to get the base to have all same sides, like 3 by 3 by 3 here, then you're golden because all of your triangles that stem from this will be the same, which is awesome. So you've got 3 triangles that are the same. You find the area for one of them and multiply times 3, then add it to the base. You're golden. But what they're saying is that if the bottom is not, if that base on the triangle is not all the same sides, then you've got this point here and you've got all different sizes of triangles. So we'll see what we come across, but be prepared. We have to do a lot of base times height divided by 2, or 1/2 of base times height. And you have to get used to that. It's part of life. All right. And the reason that we have 3 sides is, think, you've got a triangle as a base. the triangle has 3 sides. So of course, the triangles coming from this base, there can only be 4 of them. Okay, or sorry, 3 of them. Woohoo! All right, 3 sides of the triangle, 3 lateral faces. All right, you with me? All right, let's move on. So let's see what we can do. All right, so we've got find the surface area of the pyramid. Find the area of each of the face and add. The triangle base is an equilateral triangle because all 3 sides are 4 feet long. So notice that when you're looking at this is the first thing you want to do is look at that base, and if all of them are the same, then we're golden. Okay? And I don't know if they're going to be kind enough to us to always make the base on the bottom. I'm very interested to see how that's going to pan out as we go along in this book, but for right now, any time that you see one side that has all the same distances, dimensions, that means it's going to be an equilateral triangle, and we'll use that as the base. All right, so we find the area of the base, which is going to be 1/2 times 4 times the height of 3.5. Okay, that's what I used right there. Then we're going to find the area of each of these triangles that are poking up here that are the lateral faces. And we've already talked about this. If the base has all the same dimensions, then all of the sides, all the lateral faces will have the same dimensions. So we've got a base of 4 and a height of 5. So 1/2 times 4 times 5, and we find that that's going to be 10. So we know that the sides are each going to be 10 feet squared, and that the base has 7 feet squared. And so we just add all of these together, and we get our final answer, which is 37 feet squared. All right. So you're going to do example C on your own. It is, I'll give you a hint, it is an equilateral triangle. They're not trying to stump you the first time out on the gate. So you'll be lucky enough to have one base and then 3 sides that are the same. All right, so go ahead. We're not using nets yet, so go ahead and draw each of the sides out like they did here, where you have the base and then the lateral faces. Make sure that you're using the right dimensions. Remember, it has to come to a right angle. This will be the height, this will be the base. If they give you a side dimension like this, this does not go with your formula of area equals 1/2 times base times height. Okay, so don't get tricked. Okay, so go ahead, try C on your own. Pause the video now. All right, now we got lucky because when we had a base of 2 each time, we didn't have to do very much with our decimal, because 1/2 of 2 is 1, and 1 times 1.7 is 1.7. 1 times 3.5 is 3.5. So we lucked out with the math on that if you did it the same way that I did with the 1/2. So the final answer is 12.2 centimeters squared. That is the surface area of this pyramid. All right, now with D, again, yay for us, they gave us all the same dimensions on this rectangular base, or sorry, triangular base. But let me just point out, okay, this is the base. I'm just redrawing it. This side is 6, this side is 6, this side is 6. But it's telling you that this height here in the middle that comes at a right angle is 5.2. That is the height that we're going to use when we use the formula area equals 1/2 base times height. We're not using the 6 because that's a slant height. So this and this don't matter when we're finding the area of this triangle. It's just our base and our perpendicular height, which is the 5.2. All right, so go from there. Pause the video now and answer D. All right, now for this one, I just want to point out that I did the base first and got the base, and then I did the one of the lateral faces and got this, and then I knew I was going to multiply it times 3, so I just plugged it into the base plus 3 times 24.9. Because remember, if we have an equilateral triangle on the bottom, which means all 3 sides are the same, then we're going to have identical lateral bases. Yay for us. All right, so now they're going to give us an example. Oh, again, they're giving us an equilateral triangle. I guess they're not trying to trip us up at all. So the equilateral triangle, I know this because if I'm looking at this diagram, this is in the middle, so it's where my attention goes, and it's saying that both of these sides are 8 and that this side is 8. So I know this is an equilateral triangle because the base has all those same sides. Now notice that the actual height of my triangle is going to be 6.9. That doesn't make it not equilateral because the sides are 8, 8, and 8, so that's what makes it equilateral. All right, so the net is here, which I always love, so I like to color code. So I'm going to work on this. Let's see, we've got the area, we're going to find the area of the triangle in the middle, so area is 1/2 base times height, and the base is 8, and the height is 6.9. So 1/2 of 8 is 4, and we're going to do 4 times 6.9. So that's 36, carry the 3, 27. So the surface area, the area of the base is going to be 27.6 centimeters squared. Now I'm going to do the same thing with this amazing side. So we've got area equals 1/2 base times height. 1/2, the base is 8. The height is 6.9 again. I already know I don't need to do any more math, so I'm not going to fry my brains over this. Each of the sides, every one of them is identical. I've got a base of 8 and a height of 6.9. Base of 8, height of 6.9. Base of 8, height of 6.9. So I know that all 4 triangles are the same, so I'm going to take my 27.6 and multiply it times 4. Oh. I've got 1 0 here, so I'm going to go over 1. So it's 110.4 centimeters squared. Ooh, I like that one. So, and they say it right here. I was playing around. So the story says that the pyramid puzzle has all sides that are equilateral triangles. And so all of the sides are equilateral triangles, if I paid attention. And then it says that the side lengths are 8 centimeters and that the slant height is 6.9. So in case they ever give that information to you, you'll have to know that that means that here's the triangle, the base is 8, and the height is 6.9, and that all sides are the same. And with a triangular pyramid, you have to know that the base is a triangle. That means that there's 3 lateral sides that go with it, since there's 3 sides to a triangle, so 4 altogether. So I like that one. That was a good example. All right, so I'm going to show the extra practice examples. I know that the video is getting kind of long and you just had to watch the 10-minute other video, but it might be worth your time to watch a couple extra examples. 14 and 15 were already done for us, so I'm just going to go through and talk about it. So number 14, we have a square pyramid, and so the base, I would find very easily, is 25 meters squared. If I were to make this, I would just do kind of a generic little net, and this is 5 by 5, and then the height I find here is 3, and so I know that for each of my triangles I'm going to have a height of 3. So 1/2 of base, which is 5, height, which is 3, so 1/2 of 15 is 7.5. And so I know that each of these are 7.5. So I've got 7.5, 7.5, 7.5, and 7.5 meters squared. And then in the center, I've got my 25 meters squared. And so I need to add all of these together. It's going to be the 25 plus 4 times 7.5, and we get 55 meters squared. And that's our final answer. And for number 15, they give us the triangular one, but they do tell us that the sides are 10, 10, and 10, so we know that's an equilateral. So we know that we just need to find the area of the base and then the area of one of the sides, and then we can multiply that times 3 when we find the area of one of the sides. So the area of our base, we are going to use our formula 1/2 times base times height, and here it is. And so that's going to be 43.5 feet squared. Then we're going to find the area of each of the faces, which again, the base is 10. This time the height is 12. And so that's going to be 60 feet squared. And there are three of those, so we're going to multiply that times 3 and add it to the base. And our final answer ends up being 223.5 feet squared. Feel free to, draw it out. If you want to have each of the pieces, here's the base, and it's 10 with a height of 8.7, and you find that. And then you take another one, and you got the base of 10 and the height of 12, and you find the area of that. And then you, put it all together, however it works. If you want to use the chart and do it that way, that's fine. I love using the net because I like to fill it in like I did here, where I put the actual stuff inside. And again, color coding is the way to go with that. All right, number 16 is an example. I want you to try this on your own. It's just some extra practice, and we'll come back to you in just a moment. All right, I thought this one was fun. All right, so we've got the base, which is a 3 by 3 square, and then we have the triangles, which have a height of 6. And again, I told you I like doing the net, so I went ahead and drew this really quick and sloppy. Then what I love to do is labeling it. So once I found the area of the square base, I plugged it in here. Once I found the area of the triangles, I plugged those in, and they're all the same. So ultimately, I knew I was going to have 9 plus 4 times 9, which is 45 yards squared. Excellent. All right, next, I want you to try 18 on your own. That one's a triangular one, and that'll be our last one, okay? I promise. All right, I'm lying because I'm actually going to make you do another one, but it won't take too long, I promise. Pause the video. All right, so the answer for this one is 278.4 meters squared. I found that the base was going to be 62.4 meters squared, and then the area of each of the lateral faces would be 72 meters squared, and so it would be, adding them all together, 278.4 meters squared. Yay! Last one. I promise this time for real. See the next slide? It's done. All right, so number 20 is a word problem. So let's go over this one together. It says a paper model of some pyramid in Egypt has a square base of 7.2 centimeters on each side. The slant height is 6 centimeters. How much paper was used to make the model? So I'm going to draw the picture. It tells me that I have a base of 7.2 by 7.2, and then I have, and because it's a pyramid, I know these are all triangles, and it says that the slant height is 6 centimeters, okay, and it's true for every single one of them. All right, so now I'm going to use these dimensions to find the surface area in centimeters squared. So the first thing I need to do is find the area of the square, which is 7.2 times 7.2. So the base is 51.84 centimeters squared. Then we're going to find the area of the triangles, which is going to be 1/2 base times height. So 1/2 of 7.2 times 6. I'm going to swap out and do 1/2 of 6 to get that taken care of right away, because 1/2 of 6 is doable. So I'm going to have 3 times 7.2, and that's ultimately going to be 21.6 centimeters squared. So these are each 21.6, 21.6, 21.6, 21.6. And I feel like when you label the picture like I am doing over and over again, it doesn't let me forget that these are all the numbers I need to add together. Okay, so now to find the answer to the problem, I'm going to do 51.84 plus 4 times 21.6. And that will be, and that comes out to 138.24 centimeters squared. Yay! So that's not going to kill you. All right, guys, so thanks if you stuck around for this long. I'm really excited for those of you that want to put the extra effort in. I know it was an extra 5 minutes added on, but I really think it was worth it. All right, guys, have a great day. I'll see you in school. Bye.